All righty. All right, so we are talking about ES 2110 statics, the midterm exam for fall of 2024. This is right before fall break. So there are two big time spots where you can take your exam. You could take it on Wednesday, which would be the 9th. Yeah, 10/9. Anytime between noon and 3 p.m. And you can take it on Thursday, the 10th, anytime between 3 and 7 p.m. You choose within this a 2-hour block. And if you have not done so yet, email me to let me know when you want to do it. All right. Now you can bring a calculator, pens and pencils. You can bring engineering comp paper, but I'll provide that for you if you don't bring it. And then you can have a formula sheet. The formula sheet is in your handwriting. Front and back. And you can have anything on it that you want. But the big thing is there's nothing photocopied. And even if a friend of yours has better handwriting than you still can't have it in his or her handwriting. You have to have it in your own handwriting. Okay. So I want you to produce it yourself. All right. There will be 4 problems. 1 is a unit conversion problem. 2 is a vector math problem. 3 is a 2-dimensional problem. And the 4th one is a 3-dimensional problem. Okay. Whoops. There we go. So here, you might have something like a balloon that's tethered by 3 ropes, or a weight suspended by 3 ropes, something like that. 2-dimensional problem, real similarly, right? You could have a boat that's being pulled by 2 tugs. You could have a flagpole with 2 tensions acting on it, something like that. The vector math problems, you need to add, subtract, do a scalar multiplication, do a vector multiplication, and to do a mixed triple. Unit conversion is going to be a rate. So in other words, like feet per second into meters per hour or something like that. And you do not have to memorize base units. I will provide them for you. So in other words, I'm not going to say convert feet per second to hours or to meters per hour, and this is how many feet per second there are in a meter per hour. But I would say this is how many feet are in a meter, this is how many seconds is in a minute, or this is how many minutes are in an hour, that sort of thing. So going back to the base units, you can do that unit conversion. And if by any chance I did leave something off, I would provide it for you. You could just ask me. So, all right, and what do you want to know?
How do you do sine, cosine, stuff?
Okay, on a 2-dimensional problem? Okay, great question. All right. So trig functions. It all starts, I'll just do the basic thing and then I'll go to what we do specifically. It always starts with a right triangle. If you have an angle here, which is called theta, this is the leg that is adjacent, meaning next to the angle theta. This is the sine opposite theta, across from, and this is the hypotenuse. Okay, the cosine of any angle is equal to the length of the adjacent leg divided by the hypotenuse. The sine of that angle is equal to the opposite, length of the opposite over the length of the hypotenuse. And you usually won't need this, but the tangent is equal to the sine of an angle over the cosine of that same angle, which is the opposite over the adjacent. How we apply this in our work is if you have a force that looks like this, we resolve it into x components and y components, and x and y are perpendicular to each other. So in other words, you can think about whatever the y component is. This is the force in the y direction, this length. This is the force in the x direction. And this is the total force. So that relates to, if this is the angle you're looking at, adjacent, opposite, hypotenuse. So the cosine of theta is equal to the f of x over the whole f. The sine is equal to the piece in the y direction over the entire force. And the tangent of that angle is the opposite over the adjacent. So what that's telling us is we can just use the lengths because the force has to exist along the structure that bears it. So the force triangle and the length triangle is the same thing. Okay, now the other piece is, when we go back here, if we know that this angle is a right angle, and we know that the sum of the three angles has to be 180. So if this is 90, this plus this, which I'll call, doesn't matter, I'll just call it gamma for now. We know that theta plus gamma has to equal 90 degrees. So it also turns out that in terms of gamma, this is the adjacent and this is the opposite. This is still the hypotenuse. So if I don't have this angle, I can either subtract this from 90 to find what this one is, or I can just work from this angle. And this angle is going to have the other sides. So in other words, if this is f of y and this is f of x, the cosine of gamma is going to equal the f of y over f. The sine of gamma is going to equal f of x over f. And the tangent of gamma is going to be the opposite, this one, f of x over the f of y. And so you can see a relationship between, I should have written this, let's do this. If I do this here, cosine of gamma, f of y over f, cosine, excuse me, sine of gamma is f of x over x, f, and the tangent of gamma is equal to f of x over f of y. So you can see that there's a relationship between those. So does that help, or did you have a different question in mind?
Putting it
Into a problem? Okay, sure, absolutely. Let's take a look. Let's take a look. Ah. I like this one better. I started to pull one of those out and I saw this one. I thought this will show us. Okay, so like if we look here at 243, you can see that you have a weight being suspended by two cables. And what you can see is this is a triangle, isn't it? In other words, 50, 30, it's not a right triangle. So this is gonna, the three of these will add up to be 180. So if these are 80, this is 110. But we can just look at the force in AC as being a right triangle, sorry? Is it 150 plus 30 is 80, so this is 100, yes, exactly. But for our purposes, we can look at these two right triangles instead because we're resolving into X and Y. All right, so how would I do that? Well, the first thing I do is to draw a free body diagram. So I draw the weight pulling down. I draw TAC acting in this direction. And I have CB acting in this direction. I know that the angle this makes with the horizontal is 30. The angle this makes with the horizontal is 50. All right, so if we look at AC, this would be my AC in the X direction. This would be my AC in the Y direction. Oops, there we go. And I know that the angle it makes with the horizontal, which is the same as the X direction, is 50. Okay, so this is the hypotenuse. And for the 50-degree angle, this is my adjacent leg because it's right next to it. And this is across from it or opposite. So that means that if I want to look for ACX, I can start by saying the cosine of 50 degrees is equal to the adjacent leg over the hypotenuse, which is going to equal ACX over AC. Okay, then similarly, I can say the sine of 50 degrees is equal to the opposite, which is ACY over AC. Okay, now if I do the same thing here for CB, I can say, here's CB. This angle is 30 degrees. This is CBY, this is CBX. CBX is adjacent, so I can say the cosine of 30 degrees is equal to the adjacent leg CBX over CB. And the sine of 30 degrees is equal to CBY over CB. All right, now, what about my weight? My weight is vertical, so my weight is just my weight in the Y direction. That's all I have. All right, so to work a problem like this, it wants to know the cable tensions here. That means directed along each one of those cables. So the way I work that out is in order for this to be in equilibrium, the summation of forces in the Y direction has to be equal to 0, and the summation of forces in the X direction has to be equal to 0. In the X direction, the weight has no component because it's purely vertical. So in the X direction, I can say the force in AC in the X direction plus the force in AB, CB in the X direction. Those two things added together have to equal 0. All right, so let's go back here. Here is my AC in the X direction. If I use this equation, I can rearrange it and I can say cross multiply AC times the cosine of 50 degrees is equal to AC in the X direction. The only difference is I see that my arrow is pointing to the left, which means it's negative. CB in the X direction is positive because it points to the right. I can use this and I can say plus CB times the cosine of 30 degrees in the x direction. Those are the only two x directional forces, so that equals 0. In the original problem, it tells me that this weight is 400 pounds and it acts downward because gravity makes it act downward. Okay, so I can do a similar thing in the y direction. The first thing I notice is that both cables pull up, so the component of the tension in each cable is positive. So here I can see AC times the sine of 50, because that's ACY, plus, I would say, CB in the y direction, minus 400 pounds equals 0. So this is AC in the y direction. Using this, I can say plus CB times the sine of 30 degrees minus 400 pounds equals 0. All right. So I don't really know what AC is, and I don't know what CB is, but I can see that I have two equations and two unknowns, and mathematically I can solve for that. So since this has fewer terms, I would start by solving this equation for either CB or AC in terms of the other one. So I'm going to solve for CB by pulling the first term over to the other side. CB times the cosine of 30. When it becomes to the other side of the equation, it becomes positive, equals AC times the cosine of 50. Then to isolate CB, I divide by the cosine of 30. And I don't know what this I don't know what this value is, but I can find it pretty quickly. Turn on my calculator, make sure I'm in degrees, not radians. And I can say cosine of 50 divided by cosine of 30. And that value is 0.742227, or CB is equal to 0.74223 times AC. Then I can plug that into the other equation right here for CB, and I'll have one equation and one unknown. Okay, so I write the first term, same as I did up here, AC times the sine of 50, plus, now instead of writing CB, I want to write what CB is equal to in terms of AC. So instead of writing CB, I'm going to write 0.74223 AC. And then that's going to be times the sine of 30 minus 400 equals 0, or I can bring that 400 as a positive over to the other side of the equation. Then I can compute these values. Here I have AC times the sine of 50. Sine of 50, the value of that is 0.766. So I write this as 0.766 times AC plus, here I have 0.74223 times the sine of 30 times AC. So I'm going to multiply 0.74223 times the sine of 30. And that value is 0.3711 equals 400 pounds. So then I can just factor out the AC and add these two numbers together. So this is 1.137 AC equals 400 pounds. And then I can then solve for AC by dividing both sides by that number. And that turns out to be AC is equal to 351.77. I've stayed in pounds, so that's pounds, but I have too many significant digits. This is 400. So I really should write this as either 300 or 400, but it's more logical to me to write it with 2 sig figs, 350 pounds. Now I can use that to solve for CB by plugging in the value here. But just so that I don't lose data, I'm going to use the bigger number, the more, or not the bigger number, but the more significant digits here when I do that. And then I'll round it at the end. Okay, so this tells me I have negative AC. So negative 351.77 pounds times the cosine of 50 plus CB times the cosine of 30 equals 0. So I can take this number, the 351.77, and multiply that by the cosine of 50. This value turns out to be 226.111 plus the cosine of 30. Cosine 30 is 0.866 equals 0. And there's a negative right there. I forgot to carry down. All right, so then I bring this over as a positive and I get 0.866 CB equals 226.111. It's all in pounds. So I divide both sides by 0.866. And I get a value of CB equals 261 pounds, which I would round to 260 pounds. All right. And there's the answer to both of those. Sorry? Simple enough. Do you have any, does that make sense? Is that helpful? Okay, good deal. Good deal. All right.
When you do this enough times, it's simple.
When you do it enough times, it's exactly right. It's practice, 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 but it's very confusing at first. Like I remember, I won't make you do a problem like this necessarily, but this was one that always just took me a while to think about. When you have an inclined plane and you have a package on the inclined plane, if this is say 30 degrees, okay, the weight is going to pull straight down here. All right, well, if this is 30 degrees, which one of these angles is 30 degrees? Well, the answer is this is parallel to this. And this is not really parallel to anything. But so if you want to break that up into, well, this is x f of, this is, we call this like x prime and y prime. If you want to go along the deal here. And so if you think about it, I always had to do this. If I tip this more, this angle gets bigger and this angle gets bigger. So this angle is 30 degrees, but the other way. So since these two are perpendicular, same angle. I always have trouble seeing. So the only way I can really do that is to think about if I open up this angle at the bottom of the incline, it gets bigger if I tip it more, and this angle also gets bigger. So I can't really do it. I mean, I can do it mathematically, but it's just something that makes more sense to me. Because otherwise, half the time I would make this angle be 30 degrees. That's never good. So there you go. See, that's exciting. That's really great. Yes, that's, yep. Yep. Yeah. Yes.
angles, or sorry, they're called the critical angle, yeah. And then as soon as it starts sliding, you can tip it back a little bit more, and it'll keep sliding because it takes more of an angle to get it started sliding than to keep it sliding. So that's a good experiment. So, but yeah, something like this will be problem, not like this, something like this will be problem number 3. It won't be exactly like this, but it will be similar to this on the exam.
So you kind of footprint breathing.
Now, 1 is a unit conversion, 2 is vector math, and then 3 is a 2-dimensional problem, and 4 is a 3-dimensional.
I was just saying, one of them.
Oh, yeah, that might be, yeah. So, I just kind of went through the book and I picked out problems that seemed like they would really be helpful too. So yeah, so I probably found one and I went, oh, I like this one, and then I did the next one next. So what else do you guys want to know? Yes, well, it's good. I think that's a good strategy. So, and I need to get caught up on my grading. I'm not like horribly behind, but I'm not where I would like to be for you guys. So I'll get caught up on grading this afternoon and tonight. So hopefully by 8 a.m. tomorrow, I'll have everything done. And then you'll know where you are going into midterm. But I think you guys are good. Right. And quick reporting.